The next chapter, chapter 7, is k nearest neighbors. Now I'm going to use caret and ggplot mostly, and therefore the code that I'm going to present will be different from the what we have in the textbook. Okay, what we have in the textbook will work, and in some instances I will show you that code also, but mostly we will be using ggplot for charts and caret for running the model itself. So we'll start with setting up default path to the data files, and then let's set up some libraries that we will be using. So we'll use tidyverse. So ggplot comes with that. We'll use caret. And fnn is a library that your textbook uses, and therefore, I'm going to show you some commands from that. Then PROC is for ROC chart, and gains for gains. We've already used these libraries before. So let's go ahead and run these libraries. Okay, we're going to start with loading the riding lawnmower data, which is a small data set. And that's the one that we used in class example using in Excel. So let's go ahead and run that first. So mover df is read CSV riding movers dot CSV riding movers dot CSV. So we run that, and here is the data. So it has two predictors, income and lot size, and then ownership is coded as owner and non-owner. Okay, so if we did str mover, so that's going to show you the three columns. These two are numeric, and the ownership is character. So sometimes if a procedure needs a factor for target, then you have to convert this to a factor and then give it as input. So we'll do that as and when necessary. So then we're going to do the partition now, and so far we have done partition like what? Like we find train dot index, right? And then we do a sample of n row the data set. Okay, so that's the sequence. Well, I should say sequence. So you'll get a number between 1 and that, right? And then we have to specify, suppose we want 60%, then we say, okay, I want 60% of the number of observations from this 1 through n rows. So n rows over. Now that will generate the indexes for us. Okay, so we need a close parenthesis. Okay, so 60% of 24, so 14 row numbers are selected, and then we can do a train.df as mover.df, train index as the rows and all columns, and then valid.df would be the remaining, which will be like mover.df minus train dot index all columns, right? So this is how we have done partitioning the data set into train and validate. So now we have train and validate. Okay, but when we have caret gives us a, there is a procedure in caret called create data partition. Okay, and which is a lot easier, and it also has lot more functionality than we having to brute force the index. So here we say we'll start with set seed, and I'm going to use the same seed as in the textbook. And the reason for setting seed is for the output, for the results to be reproducible. So what you get would be the same as what I get. All right, so we're going to again generate the train index, except that we're not going to use the sample. So instead, we're going to use create partition, and that's a function from procedure from caret. The first thing we specify here is the target variable, which can be used to stratify sample from the data set. So we need to specify. So here this is so the target is mover.df ownership. Okay, and then we have to specify what proportion of the data should be set up as trained data set, or how many random numbers we need to generate. So that will be point. If you want 60% train, you put 0.6. If you want 70% train, you put 0.7, and so on. Then this create partition by default generates a list of numbers. Yeah. And we cannot use a list of numbers to segregate the rows that we want in a data frame. What we want is a vector, and therefore we have to specify that list is equal to false. So this will generate for you numbers in a vector form. Okay, so there you see. So once you have that, then you can use train dot df for from mover dot df and the train index, okay, and comma, that will be for everything else, and valid dot df is from the same data frame the other rows that are not train index, and then we need to have a comma, and then we run these two, and we get the train and valid data frames. So now we need to set up a new data, okay, for which we want classification, and we'll call that new.df. Okay, and again that needs to be a data frame, and then we need to give a name for the first column and the value for the first column, the name for the second column. So there are two predictors, right? So the names must be exactly same, spelled the same, and the lowercase uppercase must be the same, right? So first one is income, okay, and we want the new data is the income equal to 60, and then the second column is lot underscore size with S uppercase. So that is equal to 20. So now run that. Okay, so there you have one observation, two variables, 60 and 20.